In this video, you will learn how to do the graph transformation in terms of the horizontal shift, in which you'd like to call it the phase shift. Yesterday, what we have been doing is vertical shift, and I hope you guys can all find out how this easy it's going to be. For this remainder of the week, I'm not going to give you anything more complicated than just to do amplitude, phase shift, and vertical shift, which you will be able to get up until this stage. We're going to be learning about these three things in total, and that's going to be it. Now for part B, where we're dealing with what we call the frequency period and those kind of things, it will require some more extra time, and I'll do that for next week. So for today, we're just going to simply be talking about the graph transformation in terms of horizontal shift here. Okay, so let's go over the basics. I always like to start with x squared. Just a little bit of a quick side note. What is the equation of f of x minus 2? Let's say. What is the graph transformation going to be here? Well, if you guys were to take a look at x squared and x minus 2 squared, because if you plug in x minus 2 into this function, these two graphs, how would the graph transformation look like? That's the question, right? So let's go to Desmos here. Let's see if this is let's see. Don't mind that song. I just were looking for something. And then so I'm gonna type in x squared and then x minus 2 squared, like that. So now you should be able to see that the graph transformation for these two things are simply just a shift from left to right. So this original graph here has now translated the exact same shape, but it will be translated 2 units to the right, because you start from 0 to 2 if you take a look at the vertex. And I can just visually able to show you here. If I were to take this graph and move it, I can see that it's matching up exactly, and you see how the bottom has moved exactly twice. So erasing that, let's see, go back to here. So the transformation is that you moved right 2. What's the major difference between the previous vertical shift is that plus 2 was at towards the end that you move up to. For horizontal shift, for anything that you will see everything inside the parentheses. Okay? Whatever's inside the parentheses, that is going to be a horizontal shift no matter what. So let's go to actual trigonometric graphs here. Okay, there we go. So sine of x. Now, if I do f of x minus pi over 2, now you would see that the graph would be x minus pi over 2. I mean, that's your equation. Okay, that's your equation. So now what is the graph transformation? Well, you would say, because it's a minus sign. Okay, notice that this is a minus sign. A lot of students ask me, okay, so if it's a minus 2, that means it's going to the left, because from the xy scale, negative direction is left and positive direction is to the right. But the negative 2 actually does the opposite effect, in which it will make it go to the right. And then if it was f of x plus 2, it will make it go to the left. So here, because it's a minus, sine of x minus pi over 2 will make it go to the right. Whereas sine of x plus pi over 2 will make it go to the left by pi over 2 exactly. Okay, so those will be the graph transformation there. Let's see in terms of graph what that's going to look like. So for sine, if you remember, all of these values will be zeros. And then you just basically go up 1, negative 1, negative 1, up 1. So we are oh, that's 2. I'm sorry. So then I'm going to erase this. We should all know the traditional graph for the sine wave that looks like this. Ooh, that looks really bad because I messed up here. So minimum, mid, maximum, mid. So there we go. So that's your regular sine wave. So now I'm going to use purple here and then see how it's going to impact sine of x minus pi over 2. So what's going to happen here, guys, if I were to give you this table here, all of these values from the positive end, which ended up being this, now this value, whatever it was, now it has to be pi over 2 added to get to the same value, because notice that if I were to plug in x as pi over 2, that means that sine of pi over 2 over pi over 2 will be the angle, right? So then that will become 0, which was our original value from here. So let me say that again. When we say x was 0 and sine of x of that was 0, we know that, right? But what is going to be sine of x minus pi over 2 then, to get the same value? Well, it turns out that if I have to plug in x as pi over 2 to get the same value there. Actually, wait a minute, that means that this is not going to be the case. So if I were to plug in x as pi over 2, this is the value that you're going to get. And that is the value that's going to end up being here, because your x is pi over 2. Okay? So whatever the sine of x minus pi over 2 was, now that's going to end up being right here. So the original graph here, whatever this was, I am moving it towards the right. Actually, I keep going back and forth, and I have to keep on switching back, so my apologies, but that would be 0. Now the only reason for that is because, I'm going to erase all this. Okay, all right, so what's going to happen is that sine of x minus pi over 2, that means that when x is pi over 2, it's going to be 0, okay? Because if I plug that in, let's say x was pi over 2, if I plug that into this graph, I'm going to get a 0 for that. Because then I'm going to get sine of 0, because pi over 2 minus pi over 2 is 0, and we know that sine of 0 is 0. Let me go to another example. Let's say that x was I don't know, pi over 2, the next one on the list. Well, what's going to happen is that if I wanted to get the same value as before, or maybe just scratch all of this out for me. Okay, let me just start over. Okay, imagine what would happen, guys, if I were to plug in 0 for here. Okay, what I'm going to get is sine of negative pi over 2. Imagine if I plug in pi over 2 into x here, I'm going to get sine of 0, because pi over 2 cancels each other out. Imagine I plug in pi into here, I'm going to get sine of pi minus pi over 2, which is sine of pi over 2. Notice how all of these values at 0, pi over 2, pi, which is the same thing here. Well, your x value, actually, what it turns out to be is your previous value. So for example, if I made one more table up here which says negative pi over 2, the next one on the list, that will be a negative 1, right? That value right there will end up here, because it's asking for sine of negative pi over 2. Sine of 0 is this value here, which is 0. Sine of pi over 2, which is the value here, which is just going to be 1. So if you take a look, the value from when x was 0, it's different, because this one says negative 1 and this one says 0. The value for pi over 2, because the x is the same, pi over 2, that ends up at 0 and this ends up being 1. So if I were to go to my chart up here, I'm going to use purple like I said, at 0, it's going to be at negative 1, because it's basically this point translated right by pi over 2. And at pi over 2, we said it was 0, right? The reason for that is this point moved to the right and then it ends up at 0. And it also turns out on the table value, it turns out to be the same thing. At pi, it's at 1. You can see where I'm going to go with this. Minimum, middle, maximum. Then it's going to go down to middle. Then it's going to go down to minimum. So my graph will look like this, and you will essentially be able to see how every single point from the red moved to the purple by moving it to the right by pi over 2. That's what it's going to be. Then this point would move to the right, move to the right, move to the right. So my graph will look like this. Of course, if I were to finish up, that point right there will be the result of this point moving to the right, which will end up at 5 pi over 2, negative 5 pi over 2, which you don't have to consider. But that's what's going to happen. So all of these values moves to the right by 1. So this value ends up negative 1. Let me use a different color here. So this ends up being -1 here. This ends up being 0, 1, 0, -1, 0, 1, 0, -1 there. And you can see how they both end up at -1s, right? Just like how this chart says. So like I said, it's going to get more complicated as the time goes by. Vertical shift and amplitude is just nothing. But it gets really complicated once I incorporate more and more of those things. Think about this question. Pause the video and see. If the table should help you, I'm going to draw out the table for you guys to have. I'm going to draw cosine and then cosine of x minus pi over 4. And you can literally make the value to be anything that you want, but you always want to start at 0. Then move it increments by pi over 2. Pi, 3 pi over 2, and then 2 pi. Then same thing here, pi over 2, 2 pi, 3 pi over 2, and then 2 pi. Well, that's all going to be negatives. Okay? So now tell me what you guys are going to get for these values here. Ooh, I have to move these two down here. Ooh. So that it matches. And then I have to draw one more table chart like this. Okay. Now, of course, if you don't have to use a table, then it's fine. But it should really help you out to see what I'm going to be dealing with. So I'm going to move it up here like that. Okay. So pause the video, draw the original cosine of x, which you should all know it starts from 0, 1, and then just draw it out, and then try to draw out a shift pi over 4 to the right. Please understand it's moving it to the right. Play it again once you're ready. Okay, so for cosine of x, what we're going to have is that it's going to start from 0, 1, and then going to move 0, -1, 0, 1, 0, -1, 0, 1. So my original graph will look something like this. Now, for the next one, what's going to happen is it's going to move by pi over 4. Now notice the before one, it moved by pi over 2. This is moving by pi over 4. So what does that mean? It means that whatever the original graph was, it moves to the right by 1 increment because each of these are half of pi over 2. So, and then this also here would be 3 pi over 4 because every one increment of these guys moves by pi over 4s. So imagine what would happen if I move this. It will end up being here, okay? And then this point will end up being here. This point will end up being here. And so you get the idea of how all of these graphs will move towards the right by ones. And then so if I were to draw this out, this point will end up being here. So it will look something like that. Now then what the big question is, what is going to be the value when it's at 0? Okay, so what is going to be this value? Well, it's really hard to say, but because if you're plugging in 0 into here, you're not going to get 1, 0, -1s anymore. You're going to get something like this. If you plug in 0 into this function, you're going to get cosine of 0 minus pi over 4. Well, what is that? Let's go back to our reference angle chart. That means we're finding cosine of negative pi over 4. Pi over 4 in degrees is 45 degrees, and I hope you realize you got to memorize that. It's root 2 over 2. And since it's in the fourth quadrant, remember, ASTC, it ends up being here with the negative angle. So this simply becomes positive value for cosine. It's root 2 over 2. So you can see how slightly it's smaller than 1. It's less than 1. But if you do root 2 over 2, that should give you 0.70, about that much. Let me just verify that just to make sense. Square root of 2 over 2 is, 0.707. So you can see how it's less than 1, and it should verify that. Let's do one more. If you do 0, actually the x value is pi over 2, right? If you plug in pi over 2 here, what's going to happen? That's cosine of pi over 2 minus pi over 4, which is the same thing as saying cosine of pi over 4, because you can reduce this is same thing as saying 2 pi over 4 minus pi over 4, which becomes pi over 4. Notice how I got the common denominator? So multiply by 2 here, multiply by 2 here, and you get that. That's standard fraction stuff. So that's cosine of pi over 4, which means what is it going to give you? It's going to give you the same thing as this one, which is 0.707. Positive, because it's in the first quadrant. So when it's at pi over 2, okay, my value, well, probably then I made, I'm talking about the red value, red points, right? Notice how the value is down here. Okay, this and this will end up being at the same value at 0.707 for here and 0.707 for there. If you're thinking of it in that scale, that's what it's going to look like. If all of this sounds like a complete gibberish to you, that's fine. What you need to worry about is then draw the original, apply the phase shift. What I like to tell my students all the time is that if you're thinking of it this so much in numerical scale, it's going to just make you more confused. It's going to make you hate this topic even more, even though you just probably don't like this topic from the beginning. You just want to draw the original shape, which is cosine of x. All deals with zeros and ones. Minimum, middle, max, and then repeat the cycle over and over again. You just have to take that graph and move it to the right or to the left based upon what they're going to give you. Okay, so you don't even need to draw this chart out. It's completely unnecessary because sometimes it's going to get really crazier than that. All you got to worry about is just the phase shift, moving to the right or to the left. Let's try this one for the last topic for today, and then we'll wrap it up. So now I'm incorporating both amplitude and the phase shift. Tomorrow, I'm going to incorporate all of those three things combined and the vertical shift. Like I said, if you keep on building on top of one another, it's going to get more complicated. So now the amplitude is 2 and the phase shift in this case is 0, but you should know that 2 sine of x would be 0, 2, 0, negative 2, 0, and then I repeat the cycle over and over again. So that's my sine graph, actually 2 sine of x. Now what's going to happen is I'm going to move it towards the left by pi over 2 because it's plus sign, right? So this point ends up being here. This point ends up being here because I'm moving it by pi over 2. That's 2 increments. That goes down here, and then that goes up here. So you can do this same rule for every single graph, and you will see in blue that, well, this point should come from here, so I probably shouldn't have drawn that. But this is the graph of 2 sine of theta minus pi over 2. Or I should just keep it consistent. Make sure that this is just theta. Okay? So, oh, I'm sorry, this is a plus. I forgot about that. That's a plus pi over 2. So because I'm moving it towards the left. If the red is the original, look at how all the red points are moving towards the left. I should be able to see that. That's the graph of a trigonometric function when we're dealing with phase shift. It's going to get more complicated, but for today, the most important thing is that you understand how to apply amplitude into the function original, and then you apply the phase shift afterwards. It's okay if you draw the original graph, because at the end, if you want to draw the final product, you just have to erase the red line, and then you should be able to see the actual answer to this question. If I'm only just going to ask you that, you could just erase the original. Or if you would just like to plot those 5 essential points from the original and then just move it towards the left. So for example, I had those 5 essential points here, 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 and here, and then just move it towards the left and then just erase those points like so, and then just connect the new dots, and then you will get the same blue graph as you see up here. Okay, I know that this video is a little bit more complicated. We'll get more in detail about this, but please for today finish up 2 questions dealing with amplitude and the phase shift. Thank you and have a great day.